Welcome. This is a continuation on the topic indices. Now, the purpose of this video is to teach you how to solve exponential equations. The first example which you are given or question is 3 to the power x is equals to 243. And what you should know about exponential equations is that if you have 3 to the power x and 243, the first thing is to try and force the 243 to be something, actually to be 3 to the power something. So this means that it requires us to break down 243. 243 is basically 3 times 3, that's 9, by 3, that's 27, by 3, that's 81, by 3, that's 243, which means that we can conclude that 243 is 3 to the power 1, 2, 3, 4, 5. Hence, we can rewrite our equation as 3 to the power x is equals to 3 to the power 5. Now, like I've just said, whenever you are given an exponential equation, the intention is to have the same bases across. Once the bases are the same, you can simply work on the powers and equate them. Hence, our x is equals to 5. Moving along, the question says 16 to the power x is equals to 4. I then recall that 16 is a square number, so it can be replaced with 4 squared. This is more like 4 to the power 1. Hence, working with the powers, you can say 2x is equals to 1. Like I said, the intention is to make the bases the same. And then once the bases are the same, you can equate the powers. Now, to solve my simple linear equation, I'm simply going to divide by 2 on both sides. Hence, x is 0.5. Now, 8x is equals to 32. When it's like this, I should find a common base. Now, using my knowledge of just basic numeracy, I know that I can turn 8 into 2 to the power 3. And then at the same time, 35 is 2 to the power 5. Actually, 32. 32 is 2 to the power 5. Now, once the bases are the same, you can simply say 3x is equals to 5. Then divide both sides by 3 to get 1 and 2 over 3 as an answer. Now, you might be tempted to turn this into a decimal. Like, I think, if I'm not mistaken, it's around 1.67. Now, I am against doing so. Reason being, if you write your answer as 1.67, 1.67 is not exact. Is not exact. So the fraction is a better answer since it is an exact answer. Now the next question says 27 to the power x is equals to 1 over 9. Obviously, the common base has to be 3 because 3 to the power 3 gives me 27. And then 9 is more like 3 squared. But then I have to remember this rule. This has been taught in previous videos. This means that 1 over 3 squared is the same as 3 to the power negative 2. which means that now, since the bases are the same, I could say that 3x is equals to negative 2. Hence, divide by 3 both sides. And then our x is negative 2 over 3. Like I said in the previous question, it is never advisable to turn this sort of fraction into a decimal because negative 0.666666 will require you to round it off to negative 0.67, which is not very exact. So it is better to leave it as x is equals to negative 2 over 3. Moving along, the question says 2 to the power x times 2 to the power x is equals to 2 to the power 4. Now, when it's like this, you have to remember that if the bases are the same, you can add the powers. Now, we basically have a scenario where you have a common base of 2. This means that I can simply take the top part, or rather the powers. X plus x is 2x, which is equals to 4. Divide out by 2 both sides. 4 over 2 is basically 2. And then the question says 3 to the power 2x divided by 3 to the power 3 is equals to 3 to the power 6. When it's like this, you have to remember that division breeds a minus. And then once the bases are the same, you can simply work with the powers. Now, this is a simple linear equation where if I take the negative 3 to the other side, it's now a positive. So I would rewrite this as 2x is equals to 6 plus 3. Now, upon having 6 plus 3, I'm going to turn it into 9. Then I divide out by 2 both sides. 9 over 2 is 4.5. I'm only allowing myself to use the decimal because this is an exact decimal. But 4.5 is also permissible. Now, the next one says 4 to the power 3x times 16 is equals to 4 to the power 14. Obviously, the first thing I have to do is to ensure that there is a common base. 16 is more or less like 4 squared. Hence, when I have a common base of 4, I can simply say 3x plus 2 is equals to 4 to the power 14. Now, once the bases are the same, just like we have been doing, you can then equate the powers. This forms a simple linear equation where if I take 2 to the other side, since it's positive, it then becomes negative. This therefore means we should rewrite this as 14 minus 2. 14 minus 2 is 12. Divide by 3, divide by 3. So our solution of x is 4. Thank you for watching.